again, Mr. Sensible here. I don't know if you've heard, you probably have, but these flat earth rascals have come up with a brand new theory that disproves gravity. Relative density disequilibrium. I think it sounds like a right load of rubbish, but they seem to think it could be the solution to all their problems. So why don't we let them tell us about it? Roll VCR. Wow, this seems exciting. It's Anthony Riley. I'm quite disappointed, really. I put in all that effort to make an exciting start, and we're presented with Sleeping Warrior. Well, I suppose we better give you a chance. So can you present us with a sound tested theory, Anthony?
Funny you should ask that question.
It's not really funny, Anthony. Come on, what's today's video about?
Today's video will be doing a little bit of science, and we will be observing how we can manipulate the medium by changing the density and create a force. Newton said where there is an acceleration, a force must be present. Today's video is all about science.
Cool. I really like science.
First, some context from a science denier with a counter to my claims from a recent video of mine. The self-proclaimed physics degree undergraduate makes a claim and gets it totally wrong. Let's consider his words carefully. This guy claims to be a man of science but doesn't know what the cause is in an experiment. Neither does Geo Whisperer.
So he's a physics undergraduate and you're going to show that he's wrong. Got to see this.
Quality between the density of the egg equal to the density of the medium it's in. But what Nora says is he equates cause with that which one manipulates. Well, your independent variable is the variable that is manipulated by the researcher in an experiment. It is the presumed cause.
Okay, Anthony, we got that. Your independent variable is the variable manipulated by the researcher in an experiment. It is the presumed cause. Won't forget. Well, let's hear first from that physics undergraduate.
Stop. The reason he's talking about this again is because he hasn't mentioned it here, but I think in this experiment, this video, they actually poured the salt in. So I think he's claiming you can change the density of the medium, and therefore that is the cause, or his independent variable is how much salt you've poured in. He hasn't mentioned this, of course, but I think that's actually what he's trying to get at. I mean, I know it seems insane what he's saying here about you have the control over the density, but he actually means that's because he's been pouring salt into it or not.
Yeah, exactly. You obviously do have the control over the density, but where's the connection from that to density is a force?
Yeah, I mean, there's exactly
no causal relation there.
Exactly, he's just gone off wildly into this quantum eraser dogma land where they prefer to live about independent dependent variables, and so he's just trying to prove forces because there's an effect as a result of changing the independent variable, i.e. the thing that is the cause in his mind. Although, of course, he doesn't like the idea of any cause has more than one factor, because, of course, you've got the density of the liquid, you've got the force of gravity. In other words, there are multiple factors, and he can't cope with that. Like, Nathan doesn't understand that an effect is the result of more than one factor. And
yeah,
so
apparently he doesn't understand that an equation can contain more than two factors.
Yeah. Yes, more than one factor. No,
more than one factor, actually.
Yeah, exactly right.
So we've got his words. We'll come back to them in a minute. It's clear that we need a definition or two for the rumpus.
At this point, Nathan shows 10 definitions. I think that's quite fair, and he said it was to avoid cherry picking. I'm not going to cherry pick either, but just to save time, I will take definitions 1 to 5 he gave, but I have no issues with any of the definitions that he showed.
From Colorado Science and Engineering Fair, the independent variable is the variable which an experimenter deliberately manipulates in an experiment.
From Penn State University, There should be three types of variables in every experiment: the dependent, independent, and the controlled. The independent variable is what is varied during the experiment. It is what the investigator thinks will affect the dependent variable.
From explorable.com, the independent variable. This is what you change in order to provide a result. The dependent variable. This is what you are measuring.
From award-winning awardco.com, an independent variable is the variable that is changed or controlled in a scientific experiment to test the effects on the dependent variable.
From the University of North Carolina. In an experiment, the independent variable is the variable that is varied or manipulated by the researcher, and the dependent variable is the response that is measured. An independent variable is the presumed cause, and the dependent variable is the presumed effect. In experiments, the independent variable is the variable that is controlled and manipulated by the experimenter, whereas the dependent variable is not manipulated. Instead, the dependent variable is observed or measured for variation as a presumed result of the variation in the independent variable.
FE is getting the message. The independent variable must be manipulated. It is the presumed cause. There can only be one independent variable. This is science.
Yes, it is science, Anthony. The independent variable is the part of the experiment that you are manipulating. The dependent variable is the part of the experiment that is affected and that you measure. But I'm not sure if you really understand what you just said. Let's have another look. These are your words based on your definitions that you presented, and I agree that they reflect the definitions. The words have your emphasis. The independent variable must be manipulated. It is the presumed cause. There can only be one independent variable. But now with proper emphasis, the independent variable must be manipulated. It is the presumed cause. There can only be one independent variable. Basically, yes, you manipulate the independent variable and you could presume that that's likely to cause the effect. It's not definite though.
Really worth being aware of what it doesn't say is science. It does not say that you can infer additional causes. You cannot substitute in or introduce or suggest alternative causes. That would fall outside scientific method because there's no citations that allow you to do it.
Anthony, you don't just infer alternatives or just suddenly supply other alternative causes, but you do have to make sure that your experiment is properly controlled because there can be other factors. I'm now going to demolish what you've just said with an experiment with cheese. Here we are, set up and ready. Our dependent variable is a small flat earth map sitting on a counter. Our independent variable is about half a pound of cheese sat on top. My hypothesis is that if I lift a block of cheese, a flat earth map will suddenly go flying away. My null hypothesis is that when I manipulate the cheese, the map will remain in place. Let's see and measure the effect of manipulating my independent variable. Oh dear, we got quite an effect there. Perhaps the controls in our experiment aren't good, and we should look to see if there's an alternative explanation for the flat earth map flying away. Well, with time and study, I believe I can improve this experiment by controlling the extraneous effect of the fan. Now that this factor is properly controlled, we can run our experiment again and see the true effect of manipulating the independent variable. Wow, the map stays in place. So manipulating the independent variable did not have an effect. It was not the cause of the map flying away.
You cannot substitute in, or introduce, or suggest alternative causes. That would fall outside scientific method, because there's no citations that allow you to do it.
I think perhaps you need to look a little more closely about the various types of variable, causes, extraneous effects, what needs to be controlled. Don't you? Your understanding has just been demolished with cheese. Well, let's give you a chance anyway. Why don't you show us your experiment?
This is an egg. This is a parts per million counter.
It's a TDS meter.
Inspired by Jaron's most recent video. If you haven't checked it out, go to his channel, and it's called something like How and Why I Drink Distilled Water.
Safety note: if you're planning on drinking distilled water, please research it very carefully or seek medical advice. As well as removing impurities, all sorts of minerals and other things your body might need are removed.
He used one of these and he measured the amount of particulates per million in his tap water.
That's right, TDS, total dissolved solids. But tap water is safe.
I decided that I could apply what he used, this little bit of technology, not science, this is technology. I could apply this technology and I could perform a practical scientific experiment where I could measure the density of a medium, in this case water.
You even said it measures the impurities. It measures the total dissolved solids. It does not measure density.
And I can make this egg move all by itself with just a little bit of salt. I can observe my phenomena to be that some objects appear to float, some objects appear to sink, some objects will suspend in different mediums. My hypothesis is if I change the medium's density, the egg will move. Newton said if an object moves, a force is present.
Okay, fair enough. That's a reasonable hypothesis. And Newton was right. If an object moves, a force is present.
My null hypothesis is that if I change the density of the medium, the egg will not move. I will activate one of the hypotheses.
Again, I find your null hypothesis quite reasonable as well.
My independent variable, my presumed cause that I must manipulate in an experiment, is the density of the medium.
Wow, 3 for 3, Anthony. Good stuff. Now you've got your independent variable, the density of the water that you are going to manipulate, and that will be your presumed cause of any effect.
My dependent variable is the movement of the egg.
And now you've got your dependent variable, the egg. This is brilliant stuff, Anthony. I'm impressed.
I'll also try and keep everything else constant. The volumes of water, not will change, just the density of the medium.
10 out of 10 so far, Anthony.
Let's see how I'm going to do this. This is my egg. This is my parts per million counter. This is going to measure the parts per million of both these fluids. This is tap water, regular tap water. That is the same tap water, but it's been preloaded to save some time with some salt from this to give it a density variation. It's going to measure the density of the tap water.
No, you're measuring the parts per million total dissolved solids, not freaking density.
So while it settles down, it takes a little bit of time. Okay, that's coming in at 212 parts per million. tap water. Don't know what that means. It's just a number. It could be unicorn farts. It's just a number.
You don't know what it means. I can tell you it does not mean unicorn farts, and it does not mean density. It means parts per million, total dissolved solids. How many times do I have to tell you?
So 212 is the recorded density of this one. Mind you, I should have showed that to the camera, shouldn't I? It's going in at 214 now. So if you want to zoom in on that, it says 214 parts per million. Okay. Back to 0. When I do it to this one is saying this is 302 parts per million. Again, if you want to zoom into that, you can have a look. Okay, so basically 200 to 300. Let's try this one again. $208. Yeah, it's about 200. Then this one's about 300. Yeah, so it's 200 and 300, right? So one's got 100 more parts per million than the other. That tells me that there is a density variation between the two.
No, it tells you about the dissolve. Oh, for crying out loud. Look, I am happy to accept that the water that you preloaded with salt is denser than the plain tap water. But please, forget about your bloody meter.
So what we're going to do is we're going to see what happens when this egg is dropped into here. It sinks and it's touching the floor.
Okay.
Let's take the egg out. Now we'll see what happens when we put it into a more dense medium. So whilst that's settling down, this was done last night because it takes ages for it to dissolve and it get to a point where it's saturated. And I've got some residue at the bottom that is salt. So at the bottom at least it's getting relatively saturated. So I'm going to give it a stir to stir it up so that it evenly distributes a little bit better. Because what I'm hoping to do is get the egg so that it's just sat above the bottom of the thing. Some people will argue and complain and say that I shouldn't have stirred it, I should have left it as a gradient. It doesn't really matter. Because what we're trying to establish is, if the medium is different, does it make a displacement? Does it force a displacement? If it forces a displacement, according to Newton, there is force. This is just normal table salt from your favourite supermarket. Other supermarkets are available. We can tell that the density of the egg is equal to the part in the glass where the liquid is.
Yeah, I'll give you that. The density is either equal to or so close to that of the salt-laden water that the egg suspended. Yep.
What I'm now going to try and prove is that if I change the density of the medium, I will cause the effect by adding salt. So if I can change it, because I'm the experimenter and I'm manipulating my presumed cause, my independent variable is the medium, that egg moves, I've caused it.
Yes, presumed cause.
We know the parts per million is about 300. All we need to do is pour some of this in. Hey, what do you know? The eggs immediately moved. Didn't have to wait for that, did we? So, what's the explanation?
Well, I assume you're going to rule out unicorn farts for a start.
Well, I'm going to measure this now. This isn't going to be much more above 300. However, if it reads anything above 300, then that'll do for me. How do I reset? There we go. So the density's reading around about 309, 308, 309.
I'm not even going to say it, but I fully accept that the density has increased because you put in salt.
You can have a look at that on the camera if you want to zoom in. But I've just made the egg move. So what's the cause? Well, scientific method states that the independent variable is the presumed cause, and I presumed that changing the density of the liquid with salt would cause a displacement.
Yes, and I guess it's quite reasonable to presume that. But you can't take that for fact. You need to make sure, like in the cheese experiment, there's not something else that could possibly be causing it.
Newton's first law of motion states that every object will remain at rest unless acted upon by a force, and I've obviously created a force. The density of the medium has displaced the egg. The egg moved. That's an accelerated mass. So therefore, Newton states that there is a force. I caused it with this. So in scientific method, the cause of the displacement is this. I've caused it. I've manipulated it. I added the salt. It caused something. I did it. I'm within scientific method.
Well, Anthony, you added salt. You manipulated your independent variable of the water density, and there was an effect that was very measurable. You have a presumed cause, not necessarily the actual one, do you?
If you assert that gravity in any way caused something in this experiment, that means you are adding a secondary cause. Adding by inference. If you add a secondary cause by inference, you fall outside of scientific method because you can't infer an extra cause when you've already got one that you've manipulated. You can't infer a secondary cause and remain within scientific method.
Anthony, we're not inferring a cause. We're not adding anything. The gravity was there all the time. The gravity does have a real and measurable effect. You just haven't either controlled for it or allowed for it. You have a presumed cause, but you now need to investigate, is it the actual cause?
If you wish to move outside of scientific method, sure, be my guest. Infer that gravity caused in any way whatsoever the effect that we just witnessed, which was the egg moving. But you do so outside of scientific method. And we know by definition, if you are not complying with scientific method, you are practicing pseudoscience. I am staying within scientific method, and I am using my cause and my effect relationship, and I am demonstrating it with using this. I've changed the density of the medium, and the egg has displaced. Within scientific method, the cause is that and only that. You cannot infer extra causes. That takes you outside of scientific method. So, in anticipation of any reaction to this this experiment in the video underneath or the comments underneath, if you assert that there is gravity acting on this in any way whatsoever, you are outside of scientific method and engaged in practicing pseudoscience. Unless you can show me a citation within scientific method that allows you to disregard the cause, the salt, the medium change, and then substitute an alternative one instead, or including adding to, then you are outside of scientific method. You are practicing pseudoscience.
Manipulate the independent variable, measure the effect. The independent variable is the cause. Cheese causes maps to move. If you believe it's anything else, like a fan, then you're practicing pseudoscience. Thanks, Anthony.
Just by way of footnote, it's interesting to think that the mass of the Earth is below this table. The huge Earth ball that we're supposed to live on. And that is pulling that egg down, isn't it? Apparently. Yet when I added an extra bit of mass to this, the mass below the egg has increased. But for some reason the egg went up. If mass really attracts mass, why didn't the egg go down?
Well, I'm going to explain it to you, Anthony. And then once I've explained it, I'm going to show how your relative density disequilibrium theory is wrong. I'm going to smash it with another experiment. With cheese! Okay, Anthony, let's go through this step by step. Take your empty glass fill it with some tap water. Put an ordinary egg in it, which promptly sinks to the bottom. The reason being, its density is greater than that of water, because density is a measure of mass per unit of volume. So if you took a cubic centimetre of that egg and compared it to a cubic centimetre of the water, the egg would have a greater mass. So if we move on, because the egg has a greater mass per unit volume, signified by a slightly darker arrow, than the water, which are slightly lighter arrows, the egg is pulled more firmly downwards by gravity. Next we come along and add some salt, just as you did. When we're doing that, we are increasing the density of the water until, in this case, the arrows are the same colour. A cubic centimetre of the water is approximately the same as a cubic centimetre of the egg. We carry on adding salt until the water is much denser than the egg. So just to reiterate, now the water per cubic centimetre has much greater mass than that of the egg. So therefore the gravity has a stronger effect on the water than it does on the egg. The egg has not changed, its density has not changed, the pull on it has not changed. The pull on the medium has increased due to its greater density. Therefore, as the water is pulled down, it pushes past and under the egg, forcing it upwards. At last, the bit that I've been waiting for. We're going to conduct an experiment. This experiment will show that density is not a force, that items of different density don't exert different forces. Come with me now to my secret lab.
Okay, what we got here is a simple balance with a little hook at each end that I've made. As you can see, it's balanced. Next, we're going to use some cheese. There's cheese in a bag at each end. It's not quite enough on the one to the right, so let's add a little bit more. Get that in there. I think as near as damn it, that's balanced. Okay, so I don't know how much is in each one. It doesn't matter. They've both got the same density and they're both pulling their end of the balance down. So, Mr. Riley, your disequilibrium density, well, those are both equal density, so I guess that's why they're balanced. Let's try something. Here's the bag of cheese from the right hand end of the balance. What should we do with it? I know. Let's increase its density and make it into one solid lump. And there you go. One solid lump of cheese. Let's try and make it even more. So that's now much denser than it was before, and much denser than the cheese at the other end. Let's try it out and see what happens. Here's our balance with the single bag of still grated cheese. Here's our bag of high density cheese. Let's hang it on the other end and see what happens. Just steady it a little, save time. And what do you know? The bag on the right has dense matter in it. The bag on the left has less dense matter. And yet we've got a balance. How can this be, Anthony? If density is the force, why isn't the one on the right pulling itself down harder? I know what you're going to say. Something like, of course this bounces because they're the same weight. Yes, and what's weight? Weight is mass times acceleration. I've increased the density, but not the mass. It's the mass times acceleration caused by gravity. There is no such thing as density disequilibrium. It's just mass. The mass of the cheese. In your experiment, the mass and volume of the egg, the mass and volume of the water. You've just been busted by some cheddar cheese.
Well, that was sweet, Anthony. Real sweet. But don't take it to heart. I'm sure that even Isaac Newton was challenged by a piece of Roquefort cheese. Well, thank you to everyone, especially my subscribers, for watching Mr. Riley taken down with some cheddar cheese. If you haven't subscribed, I would be really grateful if you would. Just click the little ball in the corner. So that's almost it for today. If you like, just hang on for a bonus bitch slap from Mr. Riley. Otherwise, I'll say goodbye. See you next time. Stay sensible. Anthony, I have a marine aquarium, and for that the water needs to be very pure, which is why I've got one of these, a 4-stage reverse osmosis deionized resin filtration system. It's just counting down, flushing out any impurities. Water will flow through the bottom right canister, which is a pre-filter, the central one, which is carbon. It goes up to the long white cylinder at the top, which is a reverse osmosis filter, and then eventually down to the bottom left one, which is deionized resin. Those numbers that you can see now is 00 pp, 0 parts per million. Once my water has been through the filter and is purified down to 0 parts per million total dissolved solids, i.e. totally pure, then I can add my salt to the correct salinity for my aquarium. I use one of these, which is a refractometer. That will measure the specific gravity, which is the density of the water at 25 degrees in this case, divided by the density of the water at reference temperature. So don't ever wave round a TDS meter again, claiming it measures density. The only thing it is showing is how dense you are. Have a nice day, Mr. Riley.
Shut up and sit down.